Gold is still quite the sought-after metal today, with the industry generating almost $200 billion USD in revenue every year. The first step is to identify potential gold-bearing areas. Geologists and mining companies conduct extensive surveys, prospecting, and geological studies to pinpoint areas with promising gold deposits. This may involve analyzing geological maps, conducting soil sampling, and using advanced techniques like remote sensing or geophysical surveys. Once a potential gold deposit is identified, the site is prepared for mining operations. This involves clearing vegetation, constructing access roads, and establishing infrastructure like camps and facilities. After the site has been prepared, it's time to mine gold. Most gold comes from lode deposits, also called vein deposits, the concentration of gold and other metals in the cracks of rocks. These deposits require hard rock mining, the process of removing gold-bearing rock called ore by drilling and blasting. Miners descend more than half a kilometer on the ground, and along with them goes specialized machinery made for the drilling process. The drilling equipment consists of a long-hole drill rig, which typically includes a drill steel, a long hollow tub, a drilling machine, and a source of compressed air. The long-hole drill rig is positioned in the desired location underground. The drill steel is inserted into the rock or ore face, and the drilling machine starts rotating and simultaneously feeds the drill steel into the rock. Compressed air is forced through the center of the drill steel to assist in removing the drill cuttings from the hole. The pattern and layout of the drill holes are designed based on the specific mining plan and the characteristics of the deposit. These plans are prepared by mining experts and geologists employed by the mining company. Factors such as the size, spacing, and angles of the holes are determined to optimize fragmentation and ensure the safety and efficiency of the blasting process. After the drilling is complete, the drilled holes are prepared for the explosives. This includes cleaning the holes of any debris and installing various components like stemming, material that helps contain the explosive force, detonators, and initiators. Once all the necessary preparations are made, the explosives are carefully placed into the drilled holes, and the blast is initiated from a safe location. The explosion breaks up the rock or ore, creating fragments that can be easily handled, transported, and processed further. After blasting the rock apart with explosives, miners use what's called a mucking machine to transfer the ore to cars, headed to the main shaft and then above ground to the mill. The use of mucking machines helps streamline mining operations by automating the process of removing loose material which would otherwise require manual labor or the use of other equipment like loaders or trucks. The gold-containing material, such as ore or scrap, is first prepared by crushing and grinding it into smaller particles the size of gravel. A mill then pulverizes the gravel to the texture of beach sand. This is done to increase the surface area for subsequent chemical reactions. The factory then adds a water and cyanide solution to the pulverized ore. Another mill grinds it further into a mud-like pulp. This pulp flows into large settling tanks. The wet solids, being heavier, sink to the bottom. The water at the top drains to another area. Workers transfer the wet solids into an agitation tank and blow in air. This process is called aeration, or air agitation. The purpose of aeration is to introduce oxygen into the slurry. The oxygen sets off a chemical reaction between the cyanide and the gold trapped in the ore, triggering the gold to dissolve and leach into the surrounding water. Once the gold cyanide complex has been formed and the aeration process is complete, the slurry is sent to drum filters for filtration. Drum filters are large rotating cylindrical filters with a porous surface that allows liquids to pass through while retaining solids. As a result, the water containing the gold is separated from the solid impurities. To recover the solid gold from the loaded solution, a chemical process called precipitation is employed. Commonly used precipitation agents include zinc, carbon, or aluminum. These agents react with the gold ions in the solution to form solid gold particles. This solid is then separated from the solution through filtration, but it still carries a lot of impurities with it. To further purify the gold, it goes through a process known as smelting. The filtered material, often referred to as gold concentrate, is mixed with flux materials. This includes a concoction of chemicals like manganese dioxide, fluoride, silica flour, borax, and sodium sodium nitrate. Flux helps facilitate the smelting process by reducing the melting point of the impurities and enabling the separation of gold from other elements. The gold concentrate and flux mixture are introduced into a furnace, which is a specialized high-temperature chamber. Inside the furnace, the mixture is exposed to temperatures like 1600 degrees Celsius, causing it to melt. The smelter is rotated to ensure everything inside receives an even heat. The high temperatures effectively separate the gold from other elements present in the concentrate, such as base materials and impurities. The molten material separates into distinct layers based on their densities, with the gold sinking to the bottom due to its higher density. The impurities, known as slag, float to the surface. Workers collect the slag, and a sample is taken to ensure it carries no gold. If it does, it's poured back into the smelter until it is completely gold-free. Once the gold has settled at the bottom of the molten material, it is collected by tilting or pouring the molten mixture. The gold is typically poured into molds or casts, forming what is known as a doré bar or bullion. It's interesting to note that the doré bar or bullion obtained at the end of the smelting process is only 80% pure. To achieve the international standard of gold purity, 99.9%, the gold still needs to be further refined. Once the gold has been refined, it undergoes assaying, which is the process of determining its purity and quality. Assaying is typically performed by specialized laboratories using various analytical methods, such as fire assay, atomic absorption spectroscopy, or mass spectroscopy. The refined gold can be further processed into various forms depending on its intended use. It may be shaped into bars, coins, jewelry, or used in other industrial applications. Adhering to environmental regulations and guidelines is crucial in cyanidation processes, since the chemical carries grave environmental risks if not properly managed. Quality control procedures ensure compliance with environmental regulations and guidelines, preventing the release of excessive cyanide or other contaminants into the environment. Effective effluent treatment and waste management processes help minimize the environmental impact of the cyanidation operation.